Namaskaram everyone, welcome back to the 75th episode of Master Unreal series, and in this episode we are going to create the pawn extension component from Lyra to handle our data required by different pawn components. So we will centralize our data into a single data asset and then we will load it all the way from game mode to your components. Okay, so if you haven't seen my last episodes, I highly recommend you check that out because we have already laid down the foundation. And without wasting any time, let's get started. Okay, so do you guys remember our drill? We have a player, it has a character movement component. All the input actions that you are sending via controller are going to our pawn component, which is named gameplay component, or I must say pawn gameplay component. Now, please note, this is not an actor component, it's a pawn component. That means it can only be added in a pawn, which we added via the modular gameplay plugin. So in the last episode, I showed you how you can bind the input actions with the functions with the help of gameplay tags, and we place the mapping in the gameplay component, right? But if you have 10 characters, then you cannot repeat this every time. So what we will do, we will create a new pawn component. So it will be a central dummy that will provide all the data that is required by different pawn components of that character. Remember, both the components are present in the player character. The only difference between this and other component is that this pawn extension component will be present in every character and all other components will talk through this extension component. Okay, they will ask whatever the information is needed. So pawn extension will provide the input data that is required in this situation and ability system as well. For example, if you need to bind the input action with the ability. So this gameplay component has its requirement and the requirements are going to be part of an asset data that we are going to give to the extension component, and it will be a single file which will hold the reference of other data assets which might be required by different components. So in this situation, at this moment, this pawn gameplay needs the input data which holds the mappings. Okay, but the problem is still the same. We cannot add the data asset for this component in every character. So how this extension component will know the data? The answer to this is the player state, because I told you player state remains even if you die. So that means if you respawn, this player state will provide the data to the pawn extension of that new character. Okay, but who will provide the data to the player state? The answer to that is the game mode. It makes sense. Game mode can give the data to the player state, but how will the game mode know what is the data? So actually it's going to be you who is going to provide this data in the world settings. So if I revise the flow, the level that you are going to play where you add the game mode, you are also going to add the pawn data that is going to be loaded in that level. Okay, so when the game mode starts, the player state will get it and the pawn extension will get it, and then from there onwards pawn extension can provide that data of the other pawn components. So how this process is going to work it out, let's understand that, because that is the very crucial part. We need to understand when and where to inject the data. I'll not go in the detail of entire Unreal Engine's loading process. I will just highlight the core pillars that we need to know at this moment. So the game mode is loaded by the Unreal Engine. It makes a login call for the local player, that is basically you who is sitting behind the computer. So for you, it generates a player controller, it spawns it. The player controller spawns the player state, it initializes it, and once it is created and initialized, Unreal Engine calls the PostLogin function of this game mode, which spawns the player pawn. So we need to add the data before the player is spawned in the game. Okay, so right before this post login implementation, we will add our custom logic that will add the data in the player state, and post that the player pawn will be created, so that once the pawn is created, all the other components can request the data and the data will be available in the player state. So you are going to inject here before this post login. Okay, so you understood how the data is going to be loaded, how you are going to inject it. Now let's address the rule of thumb for the pointers, which is very important right now, because right now you are playing with the data a lot and you need to make sure that the data does not get invalid. So you need to understand the difference between a raw pointer and the object pointer and the weak object pointer. We have used raw pointer from the very beginning. We have used object pointer in the inventory system, and we have used weak object pointer in the shop system. So you have used all three. Now it's time to know the core differences so that you can set up your gas and other stuff properly. So the raw pointer is used for the immediate access, and it is temporary, which means it will get collected by the garbage collector, and it is the fastest way to access the data. So if you want to do something for a specific frame, then you use the raw pointers. When you do not want to hold the information for more than one frame, like for example calling functions, once the task is over, this get destroyed. So it's like you do not want to store it for a specific duration. You just want to use it and throw it. That's it, period. Okay. When to use the object pointer? Now this is something that you use to hold the information for longer duration. Like for example, in a class you create variables. You want to store the values like ability system, inventory item definitions, fragments, everything that is required and will be valid for a longer duration. It's not for temporary use. It is something that is going to be used for longer duration. Alright, so object pointer will keep that object alive. It will not be collected by the garbage collector. As long as the owner lives, this object pointer will live. That means the data will be there for you. But as soon as the owner is destroyed, this object pointer is gone as well. Okay, so this is like having a control over its lifetime. Okay, so for example, in case of inventory item, as long as the item lives, the fragments will live. Item is destroyed, fragments are gone. That means all the attributes are gone. Now here's a big catch. The objects that are holding these variables, which are using object pointers, if they get destroyed due to some gameplay mechanics, for example, if your enemy director needs to track of all the enemies in the map so that it can coordinate the movements and attack, then in that situation, it should not hold the reference as object pointer nor as raw pointer, because raw pointer get destroyed after a specific tick because garbage collector is keeping track, because these are temporary, and object pointer is not good choice because your enemy can be killed by the player. So in that situation, if you read a data of a destroyed actor or enemy, then it will crash your editor. So in that situation, you use the weak object pointer because that data which we are trying to store can be destroyed by the environment or by the other gameplay scenarios. So raw pointer when you want to do things for that moment, object pointer when you want to store the information and you are sure that the owner which holds the variable is going to be there. It's not going to get destroyed by the gameplay situations. You can destroy it, but the gameplay situations or the environments cannot destroy it. But if there is a chance that it can get destroyed, like for example, the shop can be unloaded by the level streaming, those situations you should use weak object pointer or the enemy example I told you. Okay, so I'll keep my camera off because I'll be accessing this space quite a lot and I want your focus to be here. And before I begin, I want to provide the solution of the last exercise we left. So we were missing the look. Let's quickly add it. Okay, so this is the mouse look function that will allow you to look around, and let's add the definition. And this is the definition. Okay, so first of all, you get the pawn. If it is not valid, then there is no point. But if it is valid, then you would like to get the input action value, get its vector 2D, and based on that direction, you add the value for your or pitch. Okay, it's as simple as that. Okay, I hope now it's pleasable to the viewers. And we will bind this function to the input action. So let's copy this, paste it in the initialize player input, and the tag, let's replace it with input tag look mouse. And this should be triggered because if you are moving, then the triggered event will be fired constantly with the updated value. And we are going to bind the function. Okay, so you have binded. Let's go back to project, hit the live coding. Awesome. Now let's go to our base player and we can remove this logic. So everything is in C++ binded. Let's try. Okay, I'm able to look around. Cool. So let's save and now let's begin our actual work. So what do we want here is that in the world settings, we want to plug the pawn data that is supposed to be played in this level, just like you define game mode. What we are going to do in the tools, new C++ class, you are going to create your own world settings. Everything that you see in the engine, almost everything is modifiable if you work with C++. Okay, so I'll search for world settings and I'm going to derive my own world settings, that is base world settings. And I'm going to create a new folder for this and I'll say game modes and everything that is associated with the higher level of management, be it a game mode, world settings, or game state, all these things will be in the game modes. So I'll select this folder and I'll create the class. Okay, once you have it, you can reload all. So this is the place where I will store my pawn data that is supposed to be loaded for my player in that level. So like I said in the presentation, every component might need their own set of data. So we are going to create a single file in which we will put the reference of all those data assets that might be required by the other components of your player in the game. So for this, I'll create one more class. I'll go to tools, new C++ class, and I will search for primary data asset and I'm going to give it base pawn data. Okay. So for now, at this moment, we have input configuration, right? So this is something that is connected with your character. So I'll put it in character and create. So at this moment, you just have your input config and later you might have more data, maybe related to gas, ability system, mappings or like that. You can add everything here. I mean the reference. So let me show you by adding first, that is our input configuration data. So that is a pointer like I explained. So this is going to be U object pointer because we want it to live till this game lives. So input config, this is where I want to put it and I will forward declare it because I don't want to access anything from inside. So we want it to be editable in the editor, but in blueprints, it should only be allowed to read, not write. Okay, this is one and we want to initialize it to null because we are expecting input config every time you create a pawn data. So I'll add a constructor that will make sure that it is set to null. Okay, let's implement the constructor and I'll make sure that input config is set to null pointer. All right, now this is the pawn data that we expect in the world settings because this contains everything. So I want to expose the variable of pawn data input. So I'll use that variable here under the protected space, not in the public. And I will say t object pointer u base pawn data default pawn data. Okay, so this is the one we are expecting and we need to expose it to blueprints. All right, so it should only be allowed in the editor, not anywhere else. Okay, this is sorted. Let's hit the live coding. All right, so now I'll go to third person and this is the base input data. I will create search for data asset and I'm going to go for base pawn data. Select and I'll say DA default pawn data. Okay. And you can see your input config is there and you can select it. Now this way you can create different input configuration and other stuff and you can add more variables into the default pawn data. So I'll save this and now let's see. In the world settings, I want that variable. So I have to tell Unreal that this is not the world settings I want to use. I have my own project settings and I'm going to search for world settings. Okay, so this is where you can change the class. You can click on it and it will ask you to restart. So restart. Okay, once it is restarted, you can see here if you type default pawn data, you will find the variable, okay, in the world settings. And now here you can select this. All right. So this is where you can provide your asset. Okay. So now let's reverse engineer. We will go to our pawn gameplay component. You can name it character gameplay. I think that is much more better because pawn is little bit generic. Okay. So that was a mistake. We'll fix that later. But for now, let's call it pawn gameplay. So this input data was a variable which you were editing in the base player's blueprint here. So we do not want to do that anymore because if we have 10 characters, we cannot do this for every character. So we are going to remove that. And I told you the data, ASC, everything that is required will be communicated via the pawn extension component. Okay, that is the source of truth or the channel where you will get all your details as a pawn component of the character. So I'll go to tools and I'll create a new C++ class, search for pawn component, and I'm going to name it pawn extension component. Okay. And I'm going to place it in my character, select it, create the class. Okay. Once it is done, you can reload. And this is where I expect my pawn data to be available so that everyone can request it. And let's create the variable that will hold the reference of pawn data. So u base pawn data, and I'll call this pawn data. And let's also mark it constant. Now what does this const mean here is that this variable can be updated. You can change the value, you can assign whatever pawn data you want to assign, but the internal variables of that pawn data cannot be changed. Although the values inside that pawn data are edit defaults only, but we are making sure that no one can do that via this variable either. Okay, so this is the pawn data and let's forward declare it. And let's create a getter and a setter. So I'll go under public space. I'll get the pawn data, but tomorrow you can change the class of the pawn data. There is a possibility. So instead of hard coding the type, I will use a template so that you can pass any type. So T star get pawn data, and we are not modifying anything. We are just returning. So return pawn data. Okay. And let's mark it template class T. And now we can cast it to the given type. Okay, so let's go to pawn gameplay component.cpp. So let's see, now we have the pawn so we can access it. And I told you how long do you want your variables to live depends on your code. So I'll use this new style of creating the variables so that they get destroyed immediately once they are out of scope. So if the pawn has the pawn extension component, so I need to check if this pawn has the pawn extension. So I'll create a static function just the way we created in the inventory system. I will repeat that concept here. So I'll go under the public space static u pawn extension components. We are going to return its pointer and we will say find pawn extension component. Okay, and now you can pass any actor and we will check whether that exists or not. So first of all, if the actor is valid or not. If it is not valid, then return null pointer, put the exclamation mark. Otherwise, you return actor find component by class in the angle brackets. Okay, so we are going to return this. A simple getter, okay, a static getter. And now we can access it here, but first we need to include it. So include character pawn extension component, and you can go for u pawn extension component, find pawn extension component in this pawn that we have just received. Okay, it is going to give us the pointer, right? So I'll copy this pointer and I'll say pawn extension. So only if the pawn extension is valid, then we will be able to access the data. So let's put it inside. Now, once we have the pawn extension, let's check if we have the data. So once you have the pawn extension, you can access the data. So if pawn extension arrow get pawn data, okay, and we need to provide the class because it's a template now. So we will say u base pawn data. All right, now this will give you the pointer to this base pawn data type variable. So let's do it, pawn data. Okay, it is returning us a constant, so constant value, so that you are not able to modify. And now let's go inside this, and now we want to check in this pawn data, is the input config data asset is present or not. So again, I'll do if constant, or let's do it right way, pawn data input. Okay, it's not showing up because we have not included, so include character base pawn data. So let's store it and make sure you do not modify it. So you base input config type, and I'll say input config. Okay, I hope you are in sync with me. This input config variable that is part of this base pawn data, we want to access this because the gameplay component just need the input actions which are part of this data asset now. Okay, so we have this, and now we can go and put this logic here. Again, you can do this in the if condition. So why I did this is because it saves you from this return thing. Okay, every time you get a variable and then you have to check. So instead of writing a lot of ifs to return or to break the code, you can do this way. But do not go more than 5. Okay, if you go more than 5, then you get in a nested hell. It's like a V shape. Okay, it's all about readability, nothing wrong or right in this situation. It's just to save the lines of code and focus on the core logic. Cool, so now you have the pawn data. Okay, so now I can use this variable here instead of input data. I do not know how you guys are able to read it, but I'll assume this dark mode is friendly for all. Okay, so now we can remove the pawn data variable from here, that is the input data. Okay, now I can remove the input data from the pawn gameplay component because now we are getting it from the pawn extension. Awesome. Let's close it. Now let's first of all resolve this data loading and processing part from bottom to top. So we know that the input config is part of pawn data which is coming from pawn extension, but someone has to load the pawn data in the pawn extension as well, because otherwise it will not be able to distribute. So first of all, we need a setter. So we will go void set pawn data, and we are expecting a constant variable, so u base pawn data pointer. And I know usually when it comes to getter or setter, we do it in header, but there is going to be little more, so I'm going to create its definition in the pawn extension. Here I will check if this input pawn data is valid or not. Now here I'm not going to use if, I'm going to use check. So what I want is, like, if this is not valid, then I want my editor to crash so that I know what went wrong, so that I can check, because this is not something we can push to production. This communication or this entire flow of setting the pawn data in the initial game load is very important to us. So if it is not working, then we need to know. So in such cases where you cannot ignore the data in availability, you use check. Okay, so we check if this input pawn data is valid or not. If it is not, then it is a problem for us. That's a mistake which cannot be ignored. We have to fix it. Okay, so this is all good. And second thing is, once the pawn data is set in the pawn extension component, you cannot edit it, because this is something that happens only in the initial game load. When the game starts, we will set the pawn data, and now you cannot modify it. So first of all, I'll make sure that the pawn data variable is not valid. So if it is valid, then we would like to return. That means we do not want to set. But if it is null, that means it is the initial game load. So I will set the value that is coming in the input. So input pawn data, sorry, my bad. So we have the function that can set the pawn data in the pawn extension. Now the next question arises, who will set it? So I told you in the presentation, we will go in the game modes, and I'll create my own game mode here. So I'll go inside tools, new C++ class, all classes, and I will search for game mode base. Okay, go for next, base game mode. Okay, you can name it whatever you want. And we are going to place it in our game modes folder. create the class. Okay, so as per the presentation and the explanation, I told you that the pawn data should live in the player state so that when you die, you can collect it from the player state. So that should be the process. So first of all, we have to set the data in the player state. So I told you in the presentation, once the player state is ready and initialized, the Unreal Engine calls the PostLogin function from the game mode. So before that PostLogin happens, which is going to spawn the pawn in the game, we want to make sure that the data exists in the player states before the player comes into the picture. When I say player, that means your base player blueprint class or whatever you want to call it, the player pawn. So once the player pawn comes into the picture, the components will also get loaded. So we have to make sure that data exists in the player state before the components query. So I'll go for public and I will override the post login so that I can do that stuff before. So virtual void post login call, and it gives you that player controller for which we are trying to do the next step. So a player controller, and it's a pointer, and I'm going to say new player, which is the one that comes with the game mode. Okay, so let's forward declare this class because we are not accessing anything from inside. Now let's create the definition. So before this post login implementation is called, I want to set the data in the player state because this only gets called when the player state is initialized. So that means player state exists in the game now, and I can request it to set or to update its spawn data. And for that, you have to go in the base player state. This is the one we are using. So we will create another object pointer here. So I'll copy this and I'm going to paste it here, and I'm going to say u base pawn data, forward declare it because we are not accessing anything from inside, and I will say pawn data. Okay, so we will hold the reference of data here, and I'm going to make sure that you're not able to modify anything inside, and I'll create a getter and a setter. So in the public space, I will just go to the pawn extension and copy the same implementation. So let's copy this and paste it here. Okay, and let's implement the definition. So I'll copy this. I'll go to base player state.cpp and I will paste it here. So first of all, again, same thing. We will make a check that it exists, because if it doesn't exist, the game will not start properly because the pawn components will not get their data and you will not have the correct gameplay, which is something we do not want. And if the pawn data exists, you cannot change it. This can only happen when the level or the game starts. Once it is set, it is set. Now you cannot update it. So same thing, I'll do pawn data is equals to input pawn data. Same thing we did in the pawn extension. Okay, so we will go to base game mode. So now the post login happens and now we need to set the data. But how do we get the data? That is in the world settings. Okay, I hope you guys are with me. From the world settings, you are setting the pawn data. So the game mode should pick it from here, set it to player state, and then when the player is spawned, the data will be set in the pawn extension and every other component can access it from the pawn extension. Okay, that was the idea. So we'll go to post login, and here I want to get the world settings. So again, we have to get the world settings. We will do if I'm going to get the world first of all, and I'm going to get the world settings, and I'm going to cast it to our a base world settings. Okay, and let's put it under the parenthesis. Great, and now we are going to store it. So it's a pointer. I'll just put it and I'll call it world settings, and I want to make sure that you do not modify it. So constant, and let's include it so that we can access the variable which is part of this class. So that is in the game modes, base world settings. Okay, now you want to get the pawn data from the world settings. So let's create a getter I will go to world settings and I'll create a public function. I'll say const pawn data pointer get default pawn data, and I'm going to return default pawn data. So this is temporary at this moment, like this world setting integration directly into the game mode. I want to implement the experience loading and all that, but step by step once we come to terms with it. Okay, right now let's just stick to simple implementation so that we can understand the core implementation of data loading, and then further we will make it more modular. And we are not modifying anything, so mark it constant. Now let's get that pawn data here, so I'll put this in the if again. U base pawn data star pawn data is equals to ws get default pawn data. Okay, so you got the pawn data with you. Now once the pawn data is with you, you will put that in the player state. So you need to get the player state. So again, a base player state, so let's include it so that we can access the function from inside. I'll do character base player states. Okay, and let's put it here. This is a pointer, and again we do not want you to modify, so constant. Now how do we get the player state? You want to get the player state of this player, so the new player controller that is coming in, you want to access it player state, and you have to make sure that this is the player state we are using. So pass the type, because this function is a template function, and now you will get your player state. And now once you have the player state, you can set the pawn data, and the pawn data that we want to pass is this one. Now what do we want? Once we have updated the player state with the pawn data, we will call this implementation, which was actually meant, which will spawn your player. And now when the player is spawned by the game mode, it will set the pawn data in the pawn extension as well. So I'm going to go in the game mode and I'm going to override another function. So virtual void spawn default pawn at transform implementation. This is the function, okay? And we are going to override it. Now there are two things it needs, of course. First of all, the controller. So a controller star new player. This is something that exists in the game mode, okay? We are just overriding it. And const f transform @spawn transform. Override. Let's create the definition. Now here we will provide the information. It is similar to that spawn node you use in the blueprints. So first of all, you need to pass the spawn parameters. So f actor spawn parameters, and I'll say spawn info. We will get the spawn info. First of all, you need to set the instigator, and we are going to get the instigator. Now why we did this? Because when you spawn, you need to tell Unreal who's responsible. By default, you do not pass it in the blueprints, but under the hood, it calls the get instigator. So we are just telling that this is the instigator, which is the game mode, who is responsible for spawning this pawn that you are going to use. Second most important thing is we do not want to store it in the disk, okay? So this might be new for some of you. So this is a very important thing in the inventory as well, and it affects how you load and save the game. I will go into detail more when we will do load and save for our game. Okay, for now I just want you to go for RF transient, which means when you save or load the game, this information or this actor does not get saved into the disk, because when you load the game, we want to spawn him again. We do not want to store the information because most of the information is static, which we already know via different settings. Third thing, which is intentional, that is spawn info dot be defer construction equals to true. Okay, what does this mean is the construction script will not run. Okay, now why we are denying it? Because first we want to set the data in the pawn extension before any other thing comes into the picture. Okay, so first let's do that. So now since you are overriding, two things you have to do. First, you have to spawn the pawn by yourself, for which we have set the information. And second, we want to add the pawn data in the pawn extension component. So first, let's spawn the player. So what player do we have to spawn? The base character or the base game character? No. If you go to your third person map, you have your game mode here. You see, you have provided the default pawn class here. So we want to get this pawn class and we have to spawn that actor. You are not going to hard code it here. You are going to use a function to get that value from the game mode variable. So we need to get the class. So we will get the class, that is via get default pawn class for controller. Okay, and you are going to pass the controller here. Now you are going to store it. So it's a class pointer and I'll say pawn class. Now if this is valid, then we would like to spawn it. Now after spawning, we want to get its spawn extension. So let's spawn it and store it. So we will get the world where we want to spawn it, and I will call spawn actor. What class are you trying to spawn? It's a pawn, and now you provide the pawn class and the transform. So spawn transform that you are receiving in the input. So spawn transform, this is determined from the player state or from the camera position. Okay, and the third thing that you give is the spawn info. Now if this was successful, then you will get the pawn. So you will store that in a variable. Okay, so we are doing exact same thing which happens when you click on the play button, right? So once you have the pawn, if it is successfully spawned, then you want to get its pawn extension component. Now we will use the static function that we created. So let's include the pawn extension so that we can access it. I'll go character pawn extension component and find pawn extension component for the spawned pawn. Now if this is valid, then we can set the value. So we'll say pawn extension. Now let's do pawn extension set pawn data. And the pawn data is, you have to get it from the player state where we have set the pawn data. Okay, we are not holding the reference of pawn data in the game mode. It's useless because game mode only needs it when you start the game, initial load. Okay, so we have to get the data from the player state. So we will create a separate function in the game mode so that even when you die and you go into the spectation state, right, you can spectate other players, and then if you want to respawn again, you will request game mode, hey please spawn me again, and the game mode will request player state to get the pawn data and inject it in the pawn extension again. So I'll create a small simple function that can get me the pawn data. So I will say const u base pawn data pointer, and let's forward declare it. I will use get pawn data for the controller and const a controller star and input controller that you are giving us. Now let's implement its definition. Okay, so first of all, if the input controller is not valid, then we are going to return it. So if input controller is not valid, return null pointer. Okay, you can do this way, or you can do the new style that I told you, the nested method. I will do if input controller is valid, otherwise return null pointer. So if the input controller is valid, then we want to get its player state. So input controller, so every controller will have the player state. Okay, so get player state a base player state, because it's a template function. You can see T here, so you need to provide the type so that it casts for you automatically. And now you can store it, and we have to check it's a pointer, so we will put this in a if again ps. All right, and we make sure that you do not modify it further, so we put a const. Great, so you got the player state. Now let's get the pawn data also and check it if it's valid or not. So if ps get pawn data, That is our U base pawn data star pawn data equals to this. And again, we want to make sure that you do not modify it. Okay, it's a template function, so we need to pass U base pawn data. Okay, great. So you have the player state, pawn data, and now you can return the pawn data. Now the beauty is you do not have to write 3 lines for input controller, player state, pawn data, and return null every time. Instead, you can do this way. All right, so this is the function that we will call here, and we will pass the new player, that is your controller. So we will pass the controller here, and you will get the pawn data, and we will set it in the pawn extension. So now the pawn extension has the pawn data, and once the pawn extension have it, everyone can access from it. Okay, there is a mistake. This is not void. We have to return the pawn. So this should be a pawn star. Okay, and this get pawn data for controller, we are not modifying anything, so we can mark it const, which means it is pure. And also let's correct it here. It should be a pawn star, and this should be pure now. Okay, there is a mistake. We are marking the player state constant, but we are trying to modify it, which we want to do. So I have to remove this const from here. And in this function, we have to now return null pointer if nothing works out. So in the C++, once you start spawn, you have to finish it as well. So we will do that once our pawn extension work is done. So here I will say spawned pawn finish spawning. Okay, and we are going to give the spawn transform, which is the input, and we have to return the spawn. So return spawned pawn, another thing. Okay, now you can hit the live coding. Now let's see. First of all, we need to change this game mode with the one we have. So I'm going to open this third person game mode that I have, class settings, and instead of using game mode base, I will use my class, that is the base game mode or the one you created. Select it, hit compile, save, and under the class defaults, you will change the player state with the one that you created. So base player state. Okay, so compile and save. Now if you play, you are here. Alright, so that's it for this episode, guys. I hope you enjoyed it. Do let me know in the comments if you have any doubts, suggestions, feedback, queries, or hurdles. And I will see you in the next episode where we will create lifecycle implementation so that the pawn components can talk to the pawn extension component for the data that they need. Okay, so if you like my work and you want to support me, the Patreon and the coffee link is in the description. Feel free to check it out, and we support both one-time and membership option. Please have a word with me before you buy any membership. So I'll see you in the next episode. Till then, take care. Bye bye.